This is the second half of the lesson on solving equations involving logarithm and exponent. So for the first half, last day we talked about solving exponential equations by converting them to logarithmic form. If they have the same common base, then you just drop the bases and then solve for x or whatever. If that's not possible, then you take the log on both sides and then solve. All right. Now this time we are solving logarithmic equations. So when we need to solve logarithmic equations, we will need to convert to exponential form. How? Have a quick look. So move all logarithmic terms to the same side. Move all non-logarithmic terms to the other side. So pretty much group the like terms together. Use log laws to convert all the log terms into a single log. So basically simplifying. And then convert the single logarithm into exponential form. And then after that, you solve. If you're dealing with a quadratic equation, then you set that equal to 0 and then factor that. Okay, and make sure you state any restrictions and remove any extraneous roots. And remember, we cannot take the log of 0 or log of a negative number. So in this case, whatever inside the function, it has to be greater than 0. So greater than, not even equal there, has to be greater than. All right. Now let's solve some questions. So for this question here, there are two ways you can solve that. I'll just show, well, let's do it one way first. Now, if you look at this, we have log base 5, log base 5. So what we need to do is combine the log. So we are going to apply the division law because we have minus. So you can write this as log base 5 and then x over x minus 1. Right hand side, there's nothing you can do, but lucky us that they are both of base 5. So if you look at this, log base 5 of this equals to log base 5 of this. So that means this must be equal to 3. So x over x minus 1 equals to 3. Then this is simple algebra. The new stuff, 30-1 stuff, solving, dealing with logarithm, we already dealt with that. So now cross multiply. So x equals to 3 times x minus 1. And then distribute the 3. So 3 times x gives you 3x minus 3 times 1 gives you 3. And then you group the x terms together. So minus x on both sides. So that means you have 2x, and then move the 3 to the other side by adding 3 to each side. Adding 3, that gives you that, and then divide both sides by 2. So that means x is actually 3/2. However, we are not done, because if you look at the question, it says solve. Yes, we did that. We found out that x is 3/2 or 1.5. Now, are there any restrictions? What are the restrictions we are talking about? So the NPVs. So probably some of you still remember from Math 20-1 last year or last semester how fun it was for the NPV. So in this case, for the NPV, we are looking at the number with the log. So this one has to be greater than 0. This one has to be greater than 0. This one is already a number. So that's a 3. So there's no way it would be 0 or less than that. So let's check for NPV. So we have to look at each term separately. So for this part here, so we have to say that x has to be greater than 0. It cannot even be a 0. Why? You can do this log base 5 0. That gives you error undefined. Okay, so that's one condition. Another condition is that this has to be greater than 0 as well. So x minus 1 has to be greater than 0. Now solve this, plus 1 to each side, so that means x has to be greater than 1. Now we have two restrictions here. One says x has to be greater than 0. The other one says x has to be greater than 1. Which one is my final answer? I don't know what your math 20-1 teacher taught you before, but this is what I would do, or what I taught my, or what I teach my 20-1 students. So I'm a visual type person, so I'm going to sketch this. So one says x has to be greater than 0. So let's say 0 is here. X has to be greater than that. And another one says, well, so that means all this. And another one says that x has to be greater than 1. So now if you look at this, which region has the most overlapping? This. So what does that mean? That means your restriction is x has to be greater than 1. If it doesn't make sense to you, let's use some numbers, plug that in and see what happens. So this one says x has to be greater than 0. Let's say 0.5. 0.5. So 0.5 is greater than 0. That's good. But is 0.5 greater than 1? No. It satisfies this condition, but not this. So if this is the restriction here, the ultimate restriction, it says x has to be greater than 1. Let's say x is 2. If x is 2, it's greater than 1, so it's okay. If x is 2, it is greater than 0. So that means it is okay. So this is my restriction. Okay. Now let's, as I mentioned when I first started this question, there are two ways you can do that. I showed you one way, I'll show you another way. Because on a second thought, I thought maybe I should show you two ways so that hopefully both ways make sense. And at least also you are aware of, for some questions like this, or quite a number of them, there is more than one way to solve that, right? So let's do it the second way. Both ways are correct, by the way. So now if you look at this, so what we can do is we put all the logs on the same side if you want. Okay, so left hand side I have log base 5 of x minus log base 5 of x minus 1, and then move this to the left hand side. So minus log base 5 of 3 to each side. Okay, so minus log base 5 of 3. So after doing that, we would end up with nothing on the right hand side. So maybe I should draw a line here to separate that. Okay, then as you can see, log base 5, log base 5, log base 5. So we can apply the laws of logarithms. So minus means divide. So log base 5, and then put everything here. X minus means divide, x minus 1. And then the 3 here, that's minus, so you divide, you put that on the bottom. We talked about why we put that on the bottom before, so I'm not going to repeat myself. If you want, you can take this over this, divide by 3, work this out yourself. Alright, so now what we need to do is to get rid of the log so that we can solve for x. How? So move the base of the log to the other side, and then the log on this side would be gone, so you end up with wrong color, x over x minus 1 times 3, and then the other side is 5 as the base for the exponent raised to the power of 0. Then we can simplify each side a bit more. So here left hand side x, and then the bottom you can distribute the 3. So 3 times x gives you 3x minus 3 times 1 gives you 3. The other side 5 raised to the power of 0, that gives you 1. Now you can cross multiply, so that means x is equal to 1 times 3x minus 3, which is same as 3x minus 3. And then you can simplify this, minus x on each side, that gives you 2x, and then add 3 to each side to get rid of the 3. Add 3 here, gone, add 3, and then divide both sides by 2, so that means x is 3/2. If you look at this is the same answer that we got with the other method that I showed you several minutes ago. Alright, so let's do more questions. You get better and get used to this. So have a look. So for this one here, that's probably one way to do that, but anyway, so I mean there's still a second way, but the second way is a little bit more quite a bit lengthier, or maybe a bit confusing to some of you. So I'm going to do it the way that was described by the notes there on the previous page. So in this case, if you look at that, group the like terms together. So just recall that for this question. The second way that we did here, it follows your notes. The first way was Cheng's way, alright? So if you look at this, so group the terms with logarithm together. So that means move this one to the other side, or you can move this one to this side, but anyway, move this to the left hand side. So log base of 5, 8x plus 4. So minus log base 5 of x plus 1 on both sides. So minus log base 5 of x plus 1, and then you will just end up with 1 on the right hand side. Now if you look at this, log base 5, log base 5, so that means we can apply the division law. So log base 5, this divided by this. So 8x plus 4 over x plus 1, right hand side is still 1. Then we get rid of the base, get rid of the log. So getting rid of the log is basically means like converting this into the exponential form. So move the base of the log to the other side and make it the base of the exponent. So left hand side 8x plus 4 over x plus 1. So move this here. So that becomes the base. 5 is now the base of the exponent, and this becomes your exponent. Right? So let's simplify this. So 5 to the power of 1 is basically 5. So cross multiply or multiply both sides by x plus 1. So 8x plus 4 equals to 5 to the power of 1 is 5 times x plus 1. Then the rest is just grade 9 math 10C algebra stuff. So 8x plus 4 equals to distribute 5 into this. 5 times x gives you 5x plus 5 times 1 gives you 5, and then group the like terms together. So minus both sides by 5x. So minus 5 gives you 3x. And this is gone, of course. And then minus 4 on each side to get rid of this. So 5 minus, so minus 4 gives you 0. You know what? I'll just do it this way. I don't want to confuse any of you. So minus 5x minus 5x, so that we end up with positive x. All right, cancel, and then to get rid of 4 here, minus 4 to both sides, gone. So that means on the left hand side I have 8x minus 5x, which gives you 3x. Right hand side, 5 minus 4 gives you 1. And then if you divide both sides by 3, so that means x is 1/3. Okay, now again we are not done. We will do the fun part, NPV. So NPV, again we have to look at each part of the log function and make sure that it is greater than 0, not equal at all, has to be greater than. So this part has to be greater than 0. And again, if this is equal to 0, log base 5 of 0 gives you error undefined. So that means 8x plus 4 has to be greater than 0. And then you just do the simple algebra. 8x is greater than negative 4. X, divide both sides by 8, that gives you negative 1/2. That's one condition or one restriction. Second restriction is here. So x plus 1 has to be greater than 1. Sorry, has to be greater than 0. So different color. X plus 1 has to be greater than 0. Oops. So x plus 1 has to be greater than 0. So if you do the math, so that means x has to be greater than negative 1. So now you have two restrictions. Which one is the final restriction? So again, you can draw this. X has to be greater than negative 1/2. And then this one says x has to be greater than negative 1. Okay, so negative 1 here. So again, find the most overlap region. So in this case, the most overlap region is when x is greater than negative 1/2. So this is my final restriction. Okay, just like what we did before, if it doesn't make sense, pick some numbers, plug that in. So this one says x has to be greater than negative 1. So let's pick x to be negative 0.75. It works here, but it doesn't work here. So if this is the restriction, look at this. X has to be greater than negative 1/2. So let's pick x to be 0. So when x is 0, it is greater than negative 1/2. Great. When x is 0, 0 is greater than negative 1. So I hope it makes sense.